introduction to blockchain. So considering the various kind of participants who are all in this session, so I would like to have some demonstrations, as well as I would like to show some illustrations in these presentations, so that everyone can easily understand this blockchain concept. So as Dr. Ramesh sir told, so this is a very new concept. So very new concept, as well as nation is trying to incorporate this blockchain in every field. Okay, so first, before introduction, before entering into the introduction session, I would like to say this blockchain is a part of security, computer security. So this is the basic introduction, and which is a very and technology which is in need technology. So that's all about. I can say it in a few words. Right. So considering the participants, I'm not much more, but would like to make everyone to understand this blockchain concepts. Okay. So first, I would like to acknowledge the authors of the content because I use some graphical images and text content and some images in my presentation. So first of all, I would like to acknowledge the authors, the original authors who have worked for this. I would like to thank for those persons. Right. For this program. So first, I'm going to start with what not the blockchain is. Because before entering into that, you should know what not it is. And then next, I would like to highlight the background idea. That means which blockchain is famous and this emerging technology. So I would like to give this background idea. And then moving for definition of the
Professor Samuel, your audio is not coming through very well.
The audio is stuck out, sir.
Yeah.
Yes, Professor. Your audio is tracking.
Yeah. Could you please check on that? Kindly check and see if you can make it
I
better.
thought that the problem is in my side, but everything is facing the same.
Hello?
I said the
Is it
problem.
okay, sir?
Better now. Better.
Okay, fine.
Yeah.
Fine.
Yeah, okay, sir.
Please go ahead. Sorry for the interruption.
Yeah, yes, sir. Yes, sir. So let me repeat the agenda. So first, I would like to start from what not the blockchain is. And then next, I would like to highlight the background idea. So why the blockchain is this much familiar, and why we are saying it as an emerging technology, why a lot of countries are incorporating this one. So I'm going to give this background idea, and then I'm going to define this one. So, and we are going to see the formal definition for the blockchain. So these three topics we are going to see it with some examples as well as some demonstrations. And for tomorrow, we are going to see the key characteristics of blockchain, key benefits of blockchain, key concepts for business, as well as the participants. So who are all going to involve in this blockchain, and we are going to see their roles. Right. So first, as I told, first we are going to see what not the blockchain is. Because whenever, actually I didn't ask this question in the beginning. So usually I ask this question in every presentation. When I asking this question, what blockchain is, most of the people will say, yeah, we know Bitcoins. We know Bitcoins, which is a very latest cryptocurrency, very familiar one. Lot of famous people and celebrities are investing in this Bitcoin. Likewise, many people will say. So most of the people think that blockchain and the Bitcoin are similar. So first, I would like to say the blockchain is not what we are thinking as it is, like that Bitcoin is not blockchain, right? So actually, blockchain will have some set of protocols, will have some set of agreements, some set of smart contracts. But this Bitcoin is making use of these blockchain concepts. That's all. So without blockchain, Bitcoin cannot be implemented. So with the help of the protocols which are all in the blockchain, the Bitcoin is implemented. So I hope most of us are from computer science background. So if we take in computer, we may have two kinds of softwares. So application software and system software. Just let me clearly explain. So if I am taking my laptop, I'm having Windows 10 as my operating system, which is equivalent to blockchain. Right? Just for example, I'm saying, right? So without Windows, that operating system, I cannot run any applications. Right? So similarly, the blockchain is. But when it comes to Bitcoin, it is like an application software. We may say example as Microsoft Office, browsers, so which are all using this operating system and run from the top of the operating system. Similarly, the blockchain is the key element. The Bitcoin is implementing its concept. So that is it. So as I told, as most of us idea is like Bitcoin is equivalent to blockchain, but actually that is not. So Bitcoin is using the concepts of blockchain. Actually, similar to Bitcoin, there are a lot of cryptocurrencies are there. All the cryptocurrencies are making use of the concepts of blockchain as well as making use of the protocol of blockchain. Like you may heard the cryptocurrency as Ethereum, Litecoin. So likewise, there are a lot of cryptocurrencies are there. The Bitcoin is a very famous one, which we are hearing in our daily life. Because I think when I start my career in the blockchain, the Bitcoin rate for one INR is 1 Indian rupee is almost 5 lakhs something. But today, if you check the Google, I think it may cross 35 lakhs or 30 lakhs something. So that much famous cryptocurrency, the Bitcoin is. Okay, that's all. So actually, the Bitcoin is not a blockchain. It just incorporates the some protocols and some key concepts from the blockchain and make use of it. Right. So this is the key thing. Now, let me start from the background idea. Why we need blockchain? Already we are having lot of security algorithms, lot of security things, lot of security related mechanisms in our computer science. But still, we need some more thing. Because in the internet era, we know in a daily life, we can see the interconnected devices are increasing drastically. So 10 years back, I think how many of you know, there will be only 10 or 15 years back, only Nokia mobiles, which is like brick, right? Nokia mobiles and some Motorola mobiles, which is like brick. But today we see in everyone's home, at that time, even that mobile phone is for home only, not for personal use. But today we see each and every person having smartphone, right? And now we are moving towards the smart watches, smart bands, Alexa like home IoT devices. Likewise, we are moving towards advanced things, advanced technical related things. And we are having everything in our home which is related to the technology. Even we can control our washing machines or refrigerators over voice. Right. So whenever these things, these interconnected or network related things increase, there is a concern related security. So we have to just improve the security too. Otherwise, it may be tampered or it may be misused by some other persons. So this is the base background idea. So with this, we are going to see why we are in need of blockchain. Actually, we are in need of a decentralized, distributed computation and information sharing platform that enables multiple authoritative domains who do not trust each other, but to cooperate, to coordinate, to collaborate in a rational decision-making process. That is the very important key thing. So we are in need of some rational decision-making process or decision-making thing, right? So let me say an example. We are using ATM cards, right? So for example, I am having a State Bank ATM card, which is, so I'm from Ramanathapuram. So we may consider my home branch is in Ramanathapuram. But for some purpose, I'm going to North India. So I want to withdraw some amount, some money. So I'm searching for that State Bank ATMs, but unfortunately, there are no State Bank ATMs. So I'm searching for other ATMs. So fortunately, I find maybe Indian Bank or Indian Overseas Bank ATM, and just I inserted the ATM card. Now I withdraw my money. Have you ever think what is the background process actually going on? Because my home branch is in somewhere, like maybe in Ramanathapuram. My home bank is a different, that is State Bank, but I'm withdrawing from some other bank. I'm withdrawing the amount from some other bank's ATM, which is in some other place, even in North India. Maybe thousands of kilometers I have crossed, but still I can take or I can withdraw the cash, whatever I want, if I have in my balance, right? So this is the rational decision-making thing, because they have to make the decision, right? So whether that IOB bank or that Indian bank ATM should take a decision whether that particular account holder belongs to which bank, and whether he is having the enough balance that which is he trying to withdraw. So likewise, it should analyze and it should take a decision. So for this, we cannot use single computer. So we are in need of some distributed computing concepts. So we are in need of some distributed or decentralized computers, which were geographically located in many places. So that's why we are saying we are in need of a rational decision-making process. For that, we are using some decentralized distributed computation and information sharing platforms, which will enable many domains, but they will not trust each other, because there may be a business competition. As per my example, so for your example, I am saying, so maybe SBI and IOB having their competition in their business level. So they may not trust each other, but for the task of withdrawing the amount, they will cooperate. They will cooperate with each other. They will coordinate as well as they will collaborate. So based on some conditions. So based on some conditions, they will do. Let's see. So with some examples, okay, how this will happen. So actually, I'm having some, I'm going to start with some traditional example. So here for this example, I'm going to introduce two persons. Maybe I named them as the girl as Alice and the boy as Bob, right? So I'm going to introduce Alice and Bob. So in a traditional network system, if they want to share something means what they will do. So for example, Alice will write a document, right? And she will send it to Bob. Maybe Bob may need some updation, or Bob may do some corrections in the document. Maybe we may consider Alice send it through the traditional email, right? And now Bob downloaded the document and he corrected or he updated something in the document, and now he sent it back to the Alice. So this is very, very traditional system. Here you see Alice doesn't have her own copy. Actually, she's sending it to the Bob. So Bob may change anything in the document, and then he may send it to the Alice. In this process, maybe Bob deletes something which Alice included, which is very important. So this may happen, right? So this is traditional system. Now, when the computer evolves, we move to the concept called the cloud computing, right? Otherwise, we may say centralized computing. So that the document will be placed in a centralized place. Yes. So consider the Google documents, right? Google Excel sheets. So the document will be in a centralized place. So anyone with the Google credentials can access the Google document, and he can give, or he or she can give the access control to their friends or neighbors. So for in this example, let us consider Alice is having, or Alice is creating a document, right? She wants to share it with, she wants to share the document with Bob. So she give the access control as edit and she share it to Bob, right? So in this is a centralized system, right? So the document is in one place, maybe as I told, it may be in a cloud area. So Alice is editing in one side and Bob is editing in one side. So by some protocols, this will not affect anything, right? Maybe in your colleges or in your institutions, this may happen. Like sometimes the colleges may give some Excel sheets in the online. So they may ask to fill you some details. So at that time, parallelly, multiple students may fill the Excel sheets. So you may see these things, right? So actually, I am saying this as a cloud environment thing, but as a centralized one. But if you think it is your, maybe our college document, or if the document is in our college server, that is a centralized one, right? So in our college server, anyone can access the file inside the college campus, and they can edit the file and they can store the file, right? So for example, I am saying that is a centralized one, right? Anyone can access this server and anyone can write the data, anyone can update the data, or anyone can delete the data too. But if the centralized server failed means, what will happen? Just forget the Google things, Google documents, Google Excel. Like consider our own college, our own institution, our own corporate as an example. We are having a centralized server which will control all the computers, or which will have the important files, which the employees or students may access these files from the centralized servers. Let's think, if that centralized server is failed, what will happen? So we cannot access the file. Yes, so we cannot access the file. Maybe sometimes centralized server may fail, or sometimes the link to the centralized server may fail. Both may happen. If these things happen, means that two persons, or the persons who are all involved in this transaction, unable to get the document or unable to do any kind of transactions. So this is a major failure in the centralized system. As well as when it comes to the security wise, so they are having only one copy. Yes, Bob and Alice are sharing the same copy. Even in our college also, they will share a same copy. For example, if you are taking a file transfer protocol, there will be only one copy of file in the centralized server, right? So anyone can change. Anyone can do any kind of change if they are having the access control, right? So here two issues are rising. One is, so there is no copy in the local machine. Okay, so there is copy only in the centralized machine. So that is the first issue. The second issue is, if the centralized machine failed means, even we cannot do any work, we cannot do any task. So for that reason, we are moving towards the decentralized architecture. Decentralized architecture, right? So only I have given this key idea. So we are moving towards the decentralized architecture. So because actually is that centralized architecture is having its own advantage, but here for this blockchain purpose, we are moving towards the decentralized thing for doing the computation, and for doing the things cooperatively, coordinatively. Right. So here I have mentioned the three architectures. You see, the first one is the centralized one. Here, there will be an coordinator node, which is in the center. So all the peer nodes or all other nodes will connected to this centralized node. You think if this centralized, actually this is having its own advantage. You see, being centralized is very easy to manage the data, very easy to control the data, as well as very easy to control the peers. But the thing, if this centralized node failed, means the peers cannot connect to the centralized node, so which causes the entire failure. So this is centralized. When it comes to decentralized thing, here actually in centralized there will be only one coordinator. In decentralized there will be n number of coordinators, and each and every coordinators will have some set of nodes. Like here, right? They will be having some set of nodes. So each and every coordinator will have some set of nodes. In case one of the coordinator, maybe this first coordinator failed, means maybe due to the system may fail or the link may fail. Failed means what this nearby node do where, so these peers will connected to the nearby coordinator. So the task will not be interrupted because of this coordinator fail. So they will immediately establish a connection with nearby coordinator. So which is a major advantage in decentralized one. Right. Similarly, in distributed also you can see the diagram itself. So every node is connected with other node. So here also the same thing. So in this distributed, there will not be any coordinator. All the things, all the peers will be acted as coordinator. They will be having some certain rules. They will be maintaining some certain contracts. So based on the contracts, they will do the task. Right. Okay. So this is the reason we are in need of some decentralized computation methodology or decentralized computation and information sharing platform, as well as they should not trust each other. They should maintain their own copies with them. Otherwise, the people may change the whoever the parties involved in this transaction may tamper the files. So that is the reason we are doing, or we are just creating this concept called as blockchain. Now, again, let me come to the same example. Right. Actually, in blockchain, what will happen is Alice will have her own copy of the document, as well as the Bob will have his own document copy. So they will actually, if they need any communication, if they need any kind of updation, they will put it over the internet, and from internet he will take and he will do the updation and he will put it internet. Again, he will the Alice can take, she can compare it with the original copy. So this is what the background idea for blockchain, right? So here actually to improve three important characteristics of security. Right. The first one is the confidentiality. Right. Confidentiality in the sense secrecy. In simple, we can say it as secrecy. Right. While we may see in our WhatsApp, we may see and at the top of the conversation, it will mention as end-to-end encryption. That means they are maintaining some secrecy. That means that message which is I'm sending should be known to me as well as the recipient. So that property is called as confidentiality. So here, when sharing the document should be only known to, or only it should be in a reader form for Alice and Bob only. So the confidentiality property should be maintained, which will be done through this blockchain. And then next, the availability. So if we want this document, we may use the document at any time, or we may need the document at any time. So that availability of the document in the internet should be always it should be in a high manner, right? Because in the internet there is a attack called as denial of service attack. That is called as denial of service. If I want to access some service in a server, means maybe the attackers, they also will try to send the same request to the server. Their ultimate goal is to that I should not get the particular service. Their goal is like that. So this should be avoided. So the availability of the resources should be made. So this will be done by increasing the hardware configurations likewise. And one more important thing in the information security is integrity. So the integrity should be maintained. So the integrity in the sense, so that is, for example, if Alice is sending a message called as, how are you? But if Bob received the message as, who are you, means, then the integrity property is violated. Actually, the letters are same. How are you and who are you? The letters are same. The only one thing is the W is, the position of the W is changed, but the entire meaning is changed. So the integrity also should be maintained. So all these things can be done through this blockchain. So now I'm going to take this to a formal definition. Right. So the formal definition of the blockchain. So here I have mentioned two definitions, but the two definitions are going to give the same meaning. So first one, the blockchain is a shared immutable ledger. Okay, so here we are going to use a ledger concept. So actually in traditional things, most of the places they will use ledger. Yes. So here we are going to use the digital ledger. That's all. So we are going to use some kind of digital ledgers, right? So, but it is a shared one. It is shared among all the participants who are all going to be involved in a particular transaction. For example, maybe in the Alice and Bob example, the previous example. So in that transaction, both the people are going to be involved. So the ledger is to be shared among those two people. Okay, but the condition is it is a immutable one. That means I cannot change anything in the ledger. I cannot change anything in the ledger. If I want to change, I have to record it as a new transaction. Right? Let me show an example for that. Now, that immutable ledger, blockchain is a shared and immutable ledger that facilitates the process of recording transactions and tracking assets in a business network. As I told, so it is used to record each and every transaction in an immutable manner, which will helpful to tracking the assets. So here, when I say assets, it may be a tangible assets like physical assets, like maybe a home, maybe a land property. Likewise, otherwise intangible assets like contracts, copyrights. Okay, something like that. So everything should be recorded in an immutable ledger so that no one can change this. Right. And one more definition is that, so it's a blockchain is an open, distributed or decentralized ledger that can record transactions between two parties in an efficient, in a verifiable, and in a permanent manner. Right. Again, it's almost the same to the previous definition. You can see here the term shared is used, here the term open is used. That's all. Okay, it's an open ledger and it is a distributed ledger. It is distributed among all the parties. The purpose of the thing is it should record all the transactions involved in those among those parties, right? So it should be in an efficient manner, because for taking this I should not take much time, right? So it should be in an efficient manner, and it should be in a verifiable manner, and it should be in a permanent way. So in here, that verifiable means, so for recording a transaction, all should agree. For recording each and every transaction, So the participants who are all going to involved in the transaction should agree those things. That so only we can record it in the ledger and the transaction will be executed. Let me say an example, right? So before going to that exact blockchain example, just for our reference, I'm keeping a traditional ledger system, right? So we know in our traditional ledger system, what will happen, right? For example, let's say a banking example. So in the olden days, and now we are using online banking, net banking, UPI transactions, so on and so forth. 20 or 30 years means we can see the ledgers in the banks, right? So now if allies want to deposit rupees 100 means civil deposit in the civil give it to the cashier. So he will maintain a ledger. So in that ledger page, he will start writing. So date. Because the date is very important, right? So that cashier will enter the date because when the cash is deposited, and he will write the mode of deposit, maybe cash or check or demand draft, and how much amount, and it is in a deposit manner, like, and when which time the allies deposited, likewise he will write. And if she likes to withdraw, means that also will be recorded in the ledger, right? So that also will be recorded, like, so in which date allies wants to withdraw the amount, and in what mode, that whether cash or DD or check, which mode she wants to withdraw, and with which timestamp. Likewise, it will record, or the cashier will record everything. The cashier or manager will record everything in the ledger. Similarly for Bob also. Here you see, in this ledger, we cannot put whitener. We cannot strike out any transactions. If I want to cancel transaction, means I have to write it as new transaction. I mean, I should not strike. So that is the norms. Even nowadays also, if we are going for some places like that handling the stocks and all, if you see the ledger means, stock ledgers means, they will not put whitener. They will not strike out anything. If anything they want to record means, or anything they want to change means, they will enter it as a new transaction, right? So similarly, here also will happen. As well as when the allies tries to withdraw 90, the cashier or the manager will check the record whether the allies can withdraw rupees 90, because if she is if her account is having less than 90 means she could not withdraw, right? So she should have at least rupees 90 in her account. Otherwise, she should not withdraw the amount. So likewise, they will verify. Right. So this is actually happened in the real world blockchain also. Right. So now I'm going to explain how this blockchain will carry the data. So for this, I'm going to use two more additional characters called Dave and Catty. Now let's start with the Dave. Now Dave is depositing rupees 100, right? So this will be recorded in the public ledger of Dave. So this is exactly the what happened in the blockchain, right? So maybe actually I have given a minimal detail, but this is what exactly happened in the blockchain. So if they want to, for a banking application example, right? So actually this will happen in all the examples, but I'm taking a simple banking application example. So in this bank, they are using blockchain concept. So now Dave is depositing rupees 100. So these four members are the participants, right? Now, whenever Dave deposited rupees 100, in the public ledger of Dave, the 100 will be recorded, like in which date he is depositing, right? And how much he is depositing, and which mode of payment he is doing depositing, and in what timestamp he is doing depositing. All these things will be assigned to a unique ID. Okay, so unique ID, because we have to identify the transaction. So the transaction can be easily identified using that unique ID. So everything will be identified to a unique ID. Right. Now, what will happen in the blockchain is this public ledger will be shared to all the participants who are all involving in this transaction. Like, see, this public ledger of Dave will be shared with the transaction of the in the public ledger will be shared with the public ledger of Bob, public ledger of Cathy, as well as public ledger of Alice. You see, so in the public ledger of Bob, it is recorded as Davis deposited ₹1,000 in the bank. So with the unique ID. Similarly, Cathy. Similarly, in the Alice. Now, Dave wants to transact ₹600 to Cathy. Right? So now they want to transact ₹600 to a Cathy. Actually, in a normal banking application that we are regularly using, so what it will happen is, right, if I want to transact 600 to someone, means I will check my balance, like I have 600 and above, so that I can transact to Cathy, right? Or I can transact to someone, right? But in blockchain, if he wants to transact 600, means this alert will be notified to all the participants. Right. So here, actually, they will maintain a smart contract. Actually, I will explain it in the tomorrow's session. What is smart contract? Right. Basically, smart contract is a predefined conditions, or all those participants will come together and they will set some rules for some transactions. So this transaction should happen when and only just these conditions are satisfied. Likewise, they will have some smart contract. So now they want to send ₹600 to Cathy. So if he wants to transfer, means all these participants should agree this transaction. Otherwise, this will not happen. So what they will do, they will check their smart contracts individually. So Bob will check his smart contracts, his copy of smart contract. The Cathy will check her copy of the smart contract, and Alice will check her copy of smart contract. For example, if the smart contract consists of if Dave is having more than 600 rupees or more than 1,000 rupees, he is permitted to do the transaction. Likewise, if the smart contract is having, means all the 4 participants will allowed to execute this transaction. So Dave can give Cathy 600 rupees. Otherwise, this transaction will not be allowed, will not be permitted by the participant. So this is the very important thing in this blockchain. So each and every participant should agree this smart contract and agree the transaction to be executed. So as per the smart contract, as I told, if he is having 1,000 rupees, he is permitted to send ₹600 to Cathy. Now, this transaction also recorded in everyone's public ledger, because he is having, Bob is having his own copy. In his copy also, this transaction will be recorded. They cannot deny that I didn't do this transaction. Likewise, he can tell. So if even he want to tamper this ledger, means other ledgers will have the same data. He cannot tamper any data. So this is the main advantage of blockchain. So no one can tamper the data. So as I said, it is a immutable one. So we cannot change the data even. So if this Dave want to do some forgery, means he can do forgery in his own public ledger only. By comparing it, the public ledger of Dave with others, we can easily trace out something is going wrong, and we can find what the thing happened, and we can easily trace out the errors, or we can easily identify the forgery things happened in this transaction. So this is the major advantage of blockchain. Now, so this thing happened. So everything will be recorded in the all the copies are everyone's copies. And also one more thing will be recorded, that is Catty is now having 600 rupees as well as Dave is having 400 rupees. This also will be recorded in the public ledger of each and everyone's copies of the public ledger. Right now, one more transaction they want to initiate. Let's consider what he is trying to do is he wants to do a transaction of 600 rupees to Alice. But what the smart condition now, actually the one more important thing is every time the smart contract will update. Okay, so they will update the smart contracts periodically. Okay, based on the transactions, based on the trends, based on the emerging things, the participants will come together and they will change the contracts, right? So now the smart contract is changed. Let's consider, actually Dave is having 400 rupees, but in this smart contract, what we are saying is if Dave is having maybe or 2,000 rupees in his account, then only Dave is permitted to do any kind of transaction. Likewise, the smart contract is written. Then all the four participants, all the three participants except the Dave will check while he trying to initiate this transaction, that is his transfer rupees 600 to Alice. Now all the three people will check the smart contract. So but the smart contract is like, if he has 1,500 in his accounts, this transaction will be permitted. But actually now Dave is having only 400 rupees. So each and every person comes to a decision like this transaction should not be executed. So this transaction will not be allowed. Even though now actually I am saying Dave is having 400 rupees. Even if he is having 1,000 rupees in his account, he is trying to send 600 rupees. But the smart contract says if one and only if he is having 1,500 rupees, then only this transaction will be permitted means. So this transaction will be declined because as per the initial condition 2, he is having only 1,000 rupees. So all these people will come to a consensus, that is a mutual agreement. So mutual agreement for executing a transaction as well as to denying a transaction. So this is how the blockchain is working. So these are the main advantage. For the first advantage is, so every transaction will be recorded and it will be given to everyone's, the copy will be given to everyone. So it cannot be, we cannot violate the things, we cannot forgery these things, because even the forgery may happen in any one copy only. In others copy, it will not happen. Right. So we can easily trace out the things. If an attack happens, means if a security violation happens, means we can easily trace out these things. Right. And the second one is based on the smart contract only, the things will be executed. So if the smart contract is saying something wrong, means the people will, that participants will not allow the transaction to be executed. So this is the major advantage in this blockchain. Now I would like to show a little demo. Okay, before that, you see why it is called as blockchain. So we say it is a secured one. It is recorded in a ledger, and every participant will have their own copy. Actually, the one more major advantage is that every transaction will be linked with another transaction or next transaction or previous transaction. So this is the major advantage. If you see, just to see this example. So here the first transaction is 6F9. When it comes to the second block, that previous transaction number is also recorded. That is secured hash function. Actually here, the confidentiality is maintained with the help of secure hash algorithm 256. Yes, we will say it as SHA 256 or SHA 256. Okay. So to maintain the confidentiality, they are using SHA 256 algorithm in the blockchain. So here, by using the SHA 256 algorithm, my message is converted to some other form and it is recorded in a block. Now, when the another block of transaction is executed, you see this block will be integrated with this and the new transaction also will be integrated. And when another transaction is executed means the previous transaction ID will be noted here and the new transaction ID. Likewise, it will go. So only it is called as blockchain. So the block of, like, now I would like to show here online demo how it will work. Right. Just a minute. Just I will share a screen. Right. So before that, let me show you one thing. I think you can see my Mozilla Firefox window. Right. So how the SHA 256 is just it's changing the data. Now you see my data part is empty. Actually, I'm using this website. Okay. So I'm using this website for the demo. Actually, there are a lot of websites are available for seeing the demo of blockchains. Now I am using this particular site. Maybe let me copy this site and I'm pasting it in the chat box too, so that you can also try to work. Okay, so just I have posted this one as well as one more URL I have. I'm posting it in the chat box. Right. So now I'm using the first one. Okay. Right. So you see for a empty data. Okay. Actually, now I am not entering any data. For the empty one, the hash function is like that. So here they are using a SHA 256 hashing algorithm to convert the data and to secure the data. You see, I am typing a single letter. You can see how it changes. So for every letter, it will change. Right. Right. So I'm going to type. So if I remove this means it will come to the older one. That means that at the beginning, this hash value is there in that one. So now I am going to type hi. Welcome to. You see, for every letters, it is changing. Right. Okay, so this is how the hash algorithm will work. Right. Now, let me take it to how the blockchain concept will work. Right. Now, here I have totally 3 participants. Right. So peer A, here peer B, and at the bottom, peer C. Right. Now you see, so actually in peer A, totally there are, I think, 5 blocks are there. Yes, totally 5 blocks are there. So which will be connected with other blocks. So you can see this one. You see, this is the first block. First block's hash function is 0. That is previous hash function because this is the first block. So there is no previous blocks. So it is 0. Now, in this particular block number 1, the hash value is 40. It's begin with 40 and 1578 something. It's going like. Now you see this value is connected to the block 2, right? You see, this is the block 2. In the block 2's previous hash value, the block 1's value is placed. You see, you can see this one. 4 zeros, 157. Here also 40157883B, something, it's going like this. Now, its hash value is 0012FA9B. Likewise, it is having Now you see, I am going to the third block. You see the same hash value which is in block 2 is linked with the block 3 in of the previous field, right? And it's having its own copy of the hash value, right? So this is for peer A, right? Let's consider they are having some empty, there is no data is passed, but some transaction is happened. So it's a 5-block transaction. There are 3 peers are going to be involved. So this is peer number A. You see peer number B. Okay, so peer number B is also having the same hash value which is present in the peer number A. You see the same 4015783B. In peer number B also the same value is there. As well as for block number 2, you see in the peer number A 4012FA9B, likewise it is there. Here also 4012FA, likewise. That means what I told in the previous slide. That means so each and every peer will have their own copies. Okay, they will maintain their own copies. Okay. So here all the 3 peers will have the same set of hash values. So same nonce and same block number. Right. Now let me say one. Actually, this 5 transaction is over. Right now, this peer B want to tamper his data. He want to deny the transaction. Let's consider. Right. So what he is doing is he is going to change the data. Actually, as I told, we are doing some just a transaction in the empty data. Right now, the peer B wants to change because he wants to deny a transaction or he wants to change a value of transaction. Let's consider. Right. So what he is doing is in the 4th transaction, he want to put some data. Right. You can see now the color is changed. Right. So before that it was green color. Now you see it changed to red color. And okay, before that, let me show the hash value of this. You see, okay, before entering the data, the hash value of the block 4 is 40 AE8BBC. Okay, this is for peer B as well as for peer A also the same 40. Sorry, in the block 4, 40 AE8BBC. Here also 40 AE8BBC, and in peer C also you can see the same values 40 A8BBC. Now peer B in his 4th block he wants to change that data. Right, he changed. Whenever he change the data, actually his public ledger will not allow to change this one, because as we know it is a immutable ledger, right? So in the definition we have seen it is a immutable ledger. So it will not allow to change. So it will not allow to change, it will warn. So what he is trying to do is he is trying to recover the hash function which is similar to the previous. Okay, that means already it is having like 4 zeros AE. Okay, so when he changed the data, the hash function changed. So now he tried to change. So by mining, that means by doing some random trial and error methods, he is changing the value. Right. So I'm doing mining. You see. So after that, the result you see, the first 4 letters comes to 0. The nonce value will be changed, but here the nonce value is right. But still the next block also that peer B should change. Okay, he also changing that too. Right. So he changed that peer B2 because if the changes will affect all the blocks, okay, which is interconnected with next one. Right. So he successfully changed the block 5 too. Right. Now, actually, these changes will be reflected only in the peer B's blockchains or peer B's public ledger. It will not affect the peer A or peer C's public ledger. You see, peer A and peer B will, sorry, peer C will be having the same hash value. You see, 000 AE 8BBC. This is for peer C. And directly I'm going to the peer A. He is also having 00 AE 8BBC. Now comes to peer B. Here also first 4 zeros are same, but the next values are same. Right? So he tried to change and he tried to do forgery by changing the hash functions too. But anyway, by comparing the other people's public ledger, like peer A's and peer C's public ledger, we can come to a conclusion that peer B wants to do some kind of transaction which is illegal in this blockchain area. So likewise, it is very, very easily traced. We can trace the that means illegal transaction or the changes in the ledgers very easy manner. So this is the major advantage of blockchain. Okay, this is what happened in the fourth block. If this peer A, peer B wants to change the first block itself, means you see all the 5 blocks will be changed. Okay, you see all now it is having 00157 here 00125A. Now I change the first block itself. You can see okay, something. Okay, just I have copied something. You see all the hash functions, all the 5 blocks hash function is changed. Right? Even he can tamper these things by he can do some trial and error method, and he can change the hash value which is seems to be the original value. But as I told, by comparing the others copy, by comparing the peer A's or peer B's copy, we can easily say the transaction is tampered or the ledger, public ledger of the peer B is tampered. That means he is involved in some kind of illegal activities. Okay, this is just this is showing without any data. Let me show one example with data, and I think almost time is running. So with this, I think I can conclude. Right. So here for your understanding, so here some transactions are there. Right. You see peer A. Right. Like it is similar to the transaction which is which I showed in the slides. Right. It's a banking transaction related thing. Right. So first the Anders is paying ₹100 in his account. So this is maintained in the hash table. So all the peers, okay, all the peers are maintaining the same thing, right? And now he want to transfer the amount to different people. You see, so actually now Anders only having the balance. So he is transferred 10 to Sophia, 20 to Lucas, 15 to Emily, 15 to Madison, right? So this is, and likewise it is going on. So now, so from this Emily is having $15. From this actually she is transferring 10 to Jaxo and 5. Madiso is having actually 15. So in that 15 he is transferred 5 to Jaxo. Likewise some transaction is going on. In this also now you see just this is the transaction. Now I want to change the transaction, right? So what I'm doing is I'm just changing the 10 to 20. Now you see everything is changed. So all other blocks hash value is changed. Even now Anders wants to, or the peer A wants to change the data by just a trial and error method, means he will change the data in his public ledger, right? He changed all the data in his public ledger. Okay, so he changed every block. So now it seems to be okay. But you see, when comparing with it with peer B, so here I think 4 zeros, 1 DC is there. Here in peer B, something is different. 4 zeros BAE, something is there. And in peer C also 4 zeros BAEB is there, right? So with this, we can easily find that peer A have done some illegal transaction, or he have committed some changes in the public ledger of his own copy, right? So likewise, it will be very, very easy to track, right? So I have actually mentioned all this with the banking example. Actually, this will be applicable for maintaining the land records, because today this land record is the very major problem, So most of the things are occupied illegally. So this can be easily we can just verify the transactions with the help of blockchain. Because nowadays, actually, without blockchain, what the people will do? So he will put the sign. So we put pata for that land, or we will give the land to someone. Likewise, easily each and every officials will escape from the things. But once if the blockchain is embedded in this land record servers, means no one will escape. If he is doing illegal action, means surely he has to face the punishment. So likewise, this blockchain will do very advanced things in the field of security, as well as this will help the governments and defense systems, as well as the private sectors to maintain that means that maintain their data in a very, very secure manner, right? So till this, I want to conclude this today's session. In tomorrow's session, we will see the next thing, like key concepts, key ideas, as well as other things.